All right, so this is number 15. Number 16, by the way, is almost exactly the same. All right, so the mass of Venus they give us in kilometers. The radius they give us I'm sorry, the mass is given in kilograms. The radius is given to us in kilometers. Calculate the surface gravity in meters per second squared. So just to keep in mind, of course, that for the Earth, the surface gravity is 9.8 meters per second squared. All right, so that's 1 g. All right, so the acceleration due to gravity, right? That's what we're looking for. Is big G times the mass of the planet or the mass of the world. It doesn't even have to be a planet. Divided by its radius squared. But the radius has to be in meters. All right, so so I've got to change this, which is actually pretty easy. Hopefully you get the idea by this time. So 66051.8 kilometers, and then we know that in 1 kilometer there are 10 to the third meters. Right, 10 to the third meters. All right, so here, let's write the numbers here. So this becomes 6.67 times 10 to the minus 11th, the universal gravitational constant, times the mass of Venus, which happens to be 4.87 times 10 to the 24th, just slightly smaller than our Earth, and then divided by, so I'm going to divide by this number, 6051, again, just slightly smaller than the Earth. That's a 5. 51.8 times 10 to the third, but we've got to square that. Don't forget, a lot of people forget to square that. All right, so and then we'll see how close it is to the value on Earth, and so we expect it to be pretty close to 9.8, right? If Venus is at least in terms of its mass and its size, its radius, if it's the same as that on Earth, we're close anyway. All right, so here we go. The surface gravity on Venus is 6.67 times 10 to the minus 11th. All right, so there's that part, times the mass of Venus, which is times 4.87 times 10, 10 to the 24th, divided by, all right, so it's going to be this, so it's going to be 6051.8 times 10 to the third, but I've got to square that, right? That's really important to square that. All right, and then so this is going to be our answer, and we're going to compare that to 9.8. So what is it compared to 9.8? So not surprisingly, it's a little bit smaller, right? It would be 8 point. So if we're going to round to one place past the decimal, it would be 8.9, right? Because it's 8.86, right? So it would be 8. So for Venus, the surface gravity would be 8.9. Of course, the units are meters per second squared. So really, you just have to come up with that number. All right, and let's do the last problem. All right, so here we go. We've got the mass of Mars, 6.4 times 10 to the 23rd. Its radius, it's like half the size of the Earth. And so we're going to calculate the surface gravity of Mars, from the surface. All right. So I might, if we have time, and I think we will, I'll do this also from the top of Mount Olympus, or, Olympus Mons. I know I keep saying Mount Olympus. All right, so the first thing is, of course, we have to change the radius to meters, right? So that's going to be 3389.5, times 10 to the third meters, right? Here, we'll just make sure that, where does that come from? In 1 kilometer, there are 10 to the third meters, all right? So the kilometers cancel, and so that becomes 3389.5 times 10 to the third, right? Meters, all right? Because you need it to be in meters to do the escape velocity equation. Sorry, not as well. It actually you need it for the escape velocity equation as well. But the acceleration due to gravity, or surface gravity, in other words, is big G times the mass of the planet divided by R. And by the way, it could also be divided by R plus the height. All right. So since if you're some height above, if this is the radius of the planet R, and if you're some height H, like on top of a mountain, right? You're some. That's not a very good looking. That's not even the peak of the mountain. Sorry about that. Anyhow, it just alters the equation slightly. All right, so for this one, the H is equal to 0, right? So this becomes really simple. This is 6.67 times 10 to the minus 11th times the mass of Mars, which is 6.4. That's a decimal. Times 10 to the 23rd. All right, kilograms, of course, divided by, so in our case, it's going to be 3389.5 times 10 to the third, but you got to square that. All right, so when we do it with the top of Mount Olympus, it's going to be pretty much the same, except for the denominator. We're going to add the height of Olympus Mons, which H turns out to be 25 kilometers. All right, so we'll do that part shortly. All right, let me just do this part first. All right, so let's clear this. All right, so it's going to be 6.67 times 10 to the minus 11th, as usual, minus 11th times the mass of Mars, which is 6.4 times 10 to the 23rd, and then divided by the radius in meters, so it's going to be 3389.5 times 10 to the third E3. But then, of course, you got to square that. All right, don't forget to square that. Squared, and then the answer is, all right. So 3 points. So if we were to, I'm just rounding it to one place past the decimal, but just for the sake of this problem, all right, for the sake of comparing it to Mount Olympus, Olympus from the top of Mount Olympus Mons, the surface gravity is going to be slightly smaller, as we're going to see in just a second. So I'm going to round this to 2 places past the decimal, just to compare in a moment. So it's going to be 3.7. What was it? 2. 3.7. I didn't really look at the calculator very well. If I can find my calculator, here we go. So 3.715. So it'd be 3.72. Just to and of course the units are meters per second squared. All right. So now what I'm going to do is I'm going to do the exact same problem, but instead of this denominator, I'm going to use I'm going to add. All right, so here, I'll just show you. All right, so here, let's just take the radius of Mars, which is 33. So 3389.5 plus the 25, right? Because they're both in kilometers, all right? So you add them in kilometers. So you add them, and then you do the conversion by just saying times 10 to the third, right? So this number becomes here. Let me pause this and erase. So it's going to be 3414.5. So this becomes three. So here, okay. It's going to look, it'll look messy if I just try to write over it. All right, so I just erased that. So it's three still there. So 3414.5. All right, and of course times 10 to the third. All right, so all right, this was before. Okay, so this is like at the base of Mount Olympus. All right, so that's using this radius right here. All right, and then now we're going to calculate it with the radius that's in there. All right, so that's here. Oh, I'm going to have to redo it. Okay, so it's going to be 6.67 times 10. My time, 10 to the minus 11th divided by. Now keep in mind, on the top of Mount Olympus, Olympus Mons, it's gravity's only going to be slightly less than because it's a little bit further from the center, right? But it's not much, right? Compared to when you compare it to the radius of the planet, which is thousands of kilometers, you're only 25 kilometers above. But still, anyhow. All right, so there's the big G, and then here times 6. Oh, I should have done this part and stored it. 6.4 times 10 to the 23rd, right? And then divided by, all right, so we're going to divide by this new height, the height at the top of Olympus Mons, which is going to be 3414.5 times 10 to the third. Right, and then of course you got to square that, right? We still have to square it. All right, so what is this number going to look like compared to the 3.72? All right, so you can see it's definitely smaller. I mean, it's not much smaller, but yeah, I could have actually just left it as one place past the decimal, and you really would have seen it. But for this, all right, so this now becomes 3.66, right, meters per second squared. So just by lifting it, you require a smaller escape velocity, right? Because the object's already lifted up 25 kilometers. All right, so that is the end of the problems. Let's see, did I want to say anything else? I think that's it. All right, so that's problem number 16. All right, these are going to appear in one form or another. Of course, I'm going to change the numbers when you see them on the test. Test 2 part B.